All right, thanks for coming, everyone. Last session of the day, so glad you made it so far and hope you enjoyed the event. So today we're going to talk about policy as code, and we'll cover quite a few things. We'll start with why policies matter, what they mean in Kubernetes. Can you hear me now? Okay, all right. So we'll talk about what policies are for Kubernetes. We'll also dive into, do you have policies? Yeah. Okay, maybe, I don't know if, let's try with this in my hand and see if it works better. So there's policies, but there's policy as code. And I'm sure you've heard the term, much like infrastructure as code. So we'll talk about what that means and again, why it's important. And then we'll cover, Kyverno, which is a CNCF project. Now there's, so we'll cover Kyverno and talk about that. And then we'll look at some, you might, maybe it's the feedback between the two mics. Or?
So I probably sit here?
Yeah. Oh, it's that third mic.
No, yours is just breaking up pretty bad, so let's just,
Okay.
we'll just throw it on you.
You want to?
All right, that'll be $500 charge. Sure. Microphone. Yeah.
All right. So, and then we'll look at some demos and look at the lifecycle management of policies as well with Kyverno. So just quick introductions. I'm Jim Bugwadia, co-founder, CEO at Nirmata, also a maintainer of the Kyverno project, and I co-chair in the policy working group as well.
Hello, everyone. My name is Sagar Kundral. I work as a senior customer success engineer at Nirmata. Prior to this, I worked as a senior DevOps engineer at USPS. I'm a CKA certified. This is my first case study session. Really excited to share some insights and experiences with you today. Thank you.
All right, so let's dive in, right? So I'm going to start with, like I mentioned, why policies matter. And I want to articulate three reasons, or the three top reasons why you should put policies in your cluster. The first one is misconfigurations. So if you think about it, Kubernetes is probably the first platform where you really have developers, operators, and security all touching the same configuration. And think about it. If you have a deployment or a pod, there's portions in there that your developers care about. There's other portions like the pod security context that security cares about. There's other things that only ops cares about, like a node placement, kind of label or node selectors, things like that, right? So how do you manage these configurations? Who's responsible for what? So what we see is if you take that and then you take the dynamic and growing nature of Kubernetes and CNCF, misconfigurations galore like this, study shows, this was a CNCF blog post done, that on average, production clusters have about 300 plus misconfigurations, right? And these could be a number of different things that might impact performance, might impact cost, might impact other things as well, like we'll see, like security. So obviously, you as platform engineers, as Kubernetes admins, want to prevent misconfigurations as early as possible and as well as possible in this domain. The other aspect of this is if you look at any security survey or study, misconfigurations are the #1 leading cause of security incidents. And these cost millions, maybe collectively billions to our industry, right? Because anytime you leave things open, you leave things misconfigured, attackers will find a way in and they will find a way to exploit those misconfigurations. We see this all the time. And again, extremely important if you're running Kubernetes in production, at least make sure you have pod security, some workload security, and other things. And because of the, again, extensible nature of Kubernetes, you have to look at that entire stack and see how to make sure you are preventing these. Third reason, self-service, right? Today there's a lot of hype, there's a lot of buzz and excitement about platform engineering. And what does platform engineering mean versus DevOps or DevSecOps? It means you're providing self-service to developers. But how do you provide self-service without security, right? It's just impossible. So you need to make sure you bake in security and you bake this into the platforms So there are some fundamental building blocks over here, like GitOps is something you probably heard about. We talk about IAC. We're all familiar with that. So to me, if you look at the space, like the last 10 years, we have made incredible strides in terms of automation, IAC, other things of what we have done. What the next 10 years should be focused on is policy as code and automating security, right? Because if we don't solve that as a group, as an industry, we're not moving ahead, right? We're just stuck where today there's a stalemate between self-service and flexibility and driving business needs versus security, and security sort of ends up becoming a gatekeeper in its current form. So we want to change that, and the way to change that is through policy as code, as you'll see in some of these examples and can follow up on too. So all right, we talked about why policy, we went through 3 reasons, but what exactly is a policy, right? And obviously in our real world, we talk about vacation policies and expense policies, and we know all of that. But in Kubernetes, what is a policy? It's not something you're going to write down and say, developers, I want you to do these 20 things before you deploy a pod. It's a digital artifact which needs to be deployed, which needs to be part of your configuration, and needs to be enforced at every layer in your pipeline. So if you go to the Kubernetes docs, and like I mentioned from the policy working group, one of the things we did is as we looked at the docs, there was no real definition of this because it can mean so many different things to so many different folks. But what we kind of settled on is policies are just configurations that manage other configurations or behaviors. So if you think about it, Kubernetes has baked in objects like network policy or RBAC roles. That's a form of policy, right? You're governing other things, other aspects of configuration. But you could also have admission controls, like you can say, here's my default storage type for my cluster. That can be configured in an API server. That's a form of policy. You could have dynamic admission controls, which projects like Kyverno, as we'll see, or OPA Gatekeeper or others can inject policies and can inject policy as code, which give you a lot more control. You can check everything from basics like pod security to even whether my images have been signed, which registry they came from. Can I, what do I allow in terms of costs? All of that can be managed through policy. So really keeping it simple, policies are configurations that manage other configs or behaviors, right? If you think of it from that perspective, the interesting thing here, it's not just about validation and blocking, but it's about automating certain behaviors in your cluster. And in Kubernetes, many things happen in real time. So that's what you want to kind of go for with your policy management solutions. So what does policy as code mean, right? And we hear about infrastructure as code or everything as code, but what exactly does it mean and why does it matter? So to me, something as code doesn't mean you have to write all your policies in Java or Python. Doesn't mean we have to adopt any language for it. It really means we want to apply the same best practices, principles, other things we have learned in software engineering to whatever domain, in this case, policy, right? So it means you should be using version control. It means you should be doing code reviews. It means you should be doing signed commits as well as signing your artifacts, right? So all of the best practices you would tell a development team to use for your application, we should be using that for policy. So that's really what policy as code is. And there's other things. Again, this varies by organization. But I think the idea is to, again, apply those same best practices, bake policies into the lifecycle. And the way we kind of think about this is there's really 6 phases you want to care about. So when you look at policy as code, and later in the presentation, Sagar will go through each one of these and show us how Kyverno applies and what it can do. You're going to develop your policies much like you develop an application. You want to test your policies. Don't put policies into production without testing, right? Much like you wouldn't want a developer to do that with their apps. So you have to test. You have to then figure out how to distribute across your clusters. How do you manage rollouts, version changes, things like that? You have to enforce. Where do you enforce? It's not just at admission controls, as you'll see. Then you have to observe the results of the policies. Are my policies working? And what good is a policy? You might have deployed it, but if it doesn't work, it's not going to help anything, right? So you want to make sure you're getting the metrics, you're getting the data. Is it working? Is it working correctly? And can I prove that for compliance reasons? And then you want to manage policies because there's always changes. Just like with anything in software, software changes, right? That's why the soft part of it. So similarly, if you're writing policy as code, it's going to change. You need to manage versions of these across your clusters, right? So really, it's those 6 phases to keep in mind as you think about policy as code. So let's kind of now switch into Kyverno and what Kyverno is and why, again, it exists and what type of problems it solves. And then we'll tie it back into these 6 phases that we talked about. So Kyverno is a cloud-native policy engine initially created just for Kubernetes. So Kyverno grew up in Kubernetes. It acts as an admission controller, as you see in this picture. So every time there's a change in Kubernetes, any change, like even if you want to exec into a pod, that goes through the API server in Kubernetes. And in the API server, there's different phases before that request, that change gets stored into your etcd, which is your persistent store in most clusters. So the first phase is to authenticate and authorize, right? So that happens to know who's making this request and are they allowed to make that request. And if they're not allowed, that gets blocked in the API server immediately. If they're allowed, you proceed to the next phase, which is called admission review in general. And as part of admission review, there's 2 steps. Anything that provides admission controls, whether it's built into the API server or runs as an external policy engine like Kyverno, it can receive that request and it can mutate that request. So it can change things like set secure defaults, set labels, even it could, Kyverno also triggers different workflows and actions from that. But the idea is you go through a mutating, phase. And then once that's done, you go through a validation phase. So there's built-in validation for schema level validation. But then you can also validate requests and say, should I allow this or block, right? So based on your policies, again, Kyverno can block requests if required, or it can allow and create audit reports on them if you want to, let's say maybe in your test cluster, some best practices maybe you want to allow and you're going to be that strict, but in your production cluster, you want to enforce all your policies, right? So those are the different phases. And really the goal here is to really try and eliminate misconfigurations as early as possible, prevent these from happening altogether in your clusters rather than, if you're running a CSPM or something, it's nice that it tells you, but it only tells you after you've already deployed your apps, right? So what's the point? Great, you're telling me, which is valuable, but I'd rather prevent and not even have this go to my clusters. And really, the next level of this is to start automating security altogether, right? So just like we want to automate configuration for infrastructure, why not automate security as part of your pipelines as well? So that's what Kyverno is designed for. And it's very popular, of course, in the CNCF community, as well as, providing admission controls. You can run Kyverno completely as a command line tool. So you can run it as a CLI outside of clusters if you want and scan a cluster. You don't have to install anything. As well as it can provide background scanning periodically and report on things within your cluster. So it's a good way to start with an audit policy and then see how things are and then lock down or enforce other policies as you go. One other thing to just quickly add, so Kyverno, like I mentioned, started in Kubernetes and was kind of born and raised there, but last KubeCon or maybe KubeCon EU, we also announced Kyverno for non-Kubernetes workloads. So you can now run Kyverno on really any JSON payload, whether it's like a service authorization or your Terraform files, if you convert them to JSON. Kyverno can authorize or can check for any misconfigurations in your pipeline on even Docker files and things like that, right? So pretty exciting, and can lead to a lot more type of policy enforcement across, again, different types of systems you manage. A little bit of a history, right? So Kyverno is about, I'd say, 4 or 5 years old now. So fairly new as a project compared to Open Policy Agent, Gatekeeper, which started a couple of years ago, prior to Kyverno, I should say. So it was donated to CNCF in around 2020 by Nirmata. moved to incubation, and we just applied like last November or December for graduation. So it's in the queue, and this is more like at this point. In the CNCF, projects go from sandbox to incubation to graduation. And sandbox to incubation is considered like the harder step. Graduation is more you have to go through, organizational structure, other things, and project maturity in general. But all of that is in place. And you have to also go through third-party security reviews and to prepare for graduation itself. All right, so Kyverno policies are Kubernetes resources, right? So if you know how to write, or if you understand what a pod or a deployment looks like, you will know what a Kyverno policy looks like. There's no language to learn. There's no other thing, that you have to go off and study for this. And you can apply these in a very declarative manner to almost any Kubernetes built-in or custom resource, right? So this is an example on the right over here of a very simple policy that requires labels, certain labels on your pod. One interesting thing to point out is if you create a Kyverno policy on a pod, it automatically generates policy rules on deployments, stateful sets, daemon sets, things like that, which is also pretty nice because otherwise your deployment might succeed, but your pod fails and nobody knows why, right? So you want to avoid things like that, and Kyverno, because it's designed for Kubernetes, makes those type of things very simple and very intuitive for developers as well as operators, right? So there's several different rule types. Kyverno is not just about validation and enforcement of policies, but it can also be used to trigger generation of resources, like net new resources, as well as mutating either existing or mutating new resources as they're being created. There's also other rule types which are not in this slide. There's an image verification rule, which can check against an OCI registry, whether your image is assigned, whether they have the right attestations. So if software supply chain security is important to you and your organization, definitely you want to check out the image verification rule. There's also a new cleanup rule type, which can delete resources. So you can add a TTL to a resource. So let's say you want to lease a namespace. You just add a TTL to it. Kyverno will clean up when that TTL expires, right? So garbage collection, things like that become pretty easy and very efficient to do, which you will need if you're operating at a certain scale. So lots of interesting use cases, and really the power of Kyverno is when you start combining these, you could have like namespaces as a service or multi-tenancy, and you could extend that to microsegmentation with zoning. So there's many things, and we're seeing so many different use cases evolve. And also like integrating Kyverno into other projects makes it very powerful, as well as extends those type of use cases. So speaking of use cases, and I'm not going to read through all of these, but someone was asking like, okay, there's so much in Kubernetes and CNCF, where do I start? What should I do now? And how do I kind of work my way into more advanced things? So really, what I would suggest is start with pod security. If you're running any production workload, you need pod security. Either look at pod security admission. If that works for you, fantastic, use it. In most cases, unfortunately, it doesn't work for folks, so they need some other way of enforcing pod security. So look at Kyverno, look at other options, but start with pod security, right? That's the fundamental unit of deployment, of management. But then it's not just about pods. You have workloads. Workloads could be services. Workloads have ingress controllers. You might be running a service mesh. You might be running other things in your cluster. All of this needs proper configuration management, which policy as code can help with. So start looking at workloads, and then look at automation use cases. And then also, an increasing sort of area of interest is use cases for FinOps, right? So cost management becomes important. How do you make, especially with so many AI ML workloads running on Kubernetes, you might want to kind of start making sure you're enforcing quotas and budgets and things like that, which you can easily do with Kyverno. All right, so that, so far we covered, the why, the what, of policies. We talked about some of the use cases. We quickly introduced Kyverno. The next section, Sagar is going to go much deeper and start looking at actual, each one of those 6 phases for policy as code.
Thank you, Jim. All right. Now that we have looked into some of the benefits of policy as code, let us look into the different phases of policy as code lifecycle. So let's start with the develop phase. As Jim mentioned earlier, you can develop Kyverno policies in the same manner like you develop any application code, right? And since Kyverno policies are native to Kubernetes and they are written in YAML format, they are fairly simple and easy to write. And for some of the advanced use cases, we have other constructs like James Path and CEL, which is a common expression language. As Kyverno supports both of them, we can leverage that for some of the advanced use cases. Just like any other application coding, you can use standard IDE tools, which will provide you help with syntax issues and autocomplete and so on. And we also have a library with more than 300 policies to help you get started. So you can leverage that. All right, moving on from here. So just like any software, Kyverno policies have to be tested to make sure they work as expected. And with Kyverno, we have two types of tests. We have a unit test, which uses Kyverno CLI, and then we have a chainsaw test, which is an end-to-end test. We'll look into this in depth in the next slide. So in the interest of time, I'm going to jump into the demo quickly. So all right, so I think in this, we are basically testing a disallow latest stack policy. And the main configuration file here is the Kyverno test YAML file. This is a sample policy. Let's take a look at that quickly. Like I mentioned, we are testing simple manifest files here. This is a Nginx pod with a version specific tag. And then we have the second YAML file which uses the latest tag. So let's quickly go ahead and run this unit test for this policy. Maybe before that, let me talk about this test itself. So basically, we are testing the disallow latest tag policy against these two resources. And we are actually defining the policy rule name, the resource name, and the expected result. So for this first pod, the expectation is that it should pass. And for the second resource file, the expectation is it should fail. So you're predefining these results ahead of time. So let's go ahead and quickly run this. So the command to run this is Kyverno test. It basically looks for the kyverno-test.yaml in that directory. As you can see, the test has completed successfully, which means the policy is working as expected. So that's it about for this demo. So let's move on. Oh, what happened? Yes, where's the slide?
I think it's at the
right here.
bottom.
Okay. Okay, so let's talk about the chainsaw test. Chainsaw test is an end-to-end testing tool for Kubernetes operators and controllers. We have been using this internally to test all our Kyverno policies. Let's take a look at the demo of a Kyverno test in the next slide. It's not working properly. Yeah, I think in the interest of time, I'm going to skip this specific demo here. Okay, so now that we have spoken about the testing the policies, the next step is the distribute phase. As we discussed, Kyverno policies are native to Kubernetes. You can actually deploy them using kubectl or any GitOps tools, or even leverage customize, right? And what we have seen is customers are using a combination of tools like customize and GitOps, so that becomes a robust solution. Because let's say a customer may want to deploy policies across different clusters in different modes in audit or enforce. So with these tools, you can have that flexibility. Moving on from here, let's talk about enforce phase, right? So if you want zero trust or depth of defense, it is important to understand that you have to enforce policies in every layer of your every layer of your system, right? You cannot say that I have enforced policies in the pipelines. Why do I need it during admission control, right? It has to be a comprehensive solution. So you need to embed security at every layer, and with Kyverno's automated background scans, you can easily scan all the existing resources after deploying the policies. So let's talk about applying policies in the CI/CD. We'll quickly take a look at the demo. I guess. I think it's not working. Sorry about this. I think it's not working from here. All right, I think in the interest of time, I'm going to skip this here. All right, so like I mentioned, enforcing policies at every layer is important. And when you deploy policies on your cluster, there are two ways you can deploy the policy. One is you can deploy the policies in the enforce mode, or you can deploy them in the audit mode. When they are deployed in enforce mode, every request that goes to the API server is intercepted. And based on the policy, if it's compliant, it's allowed. If not, it's blocked. And if the policy is deployed in the audit mode, you have ability to see all the policy reports. So as you can see from the screen, the policy report summaries can be run using a kubectl command. So yeah, let's talk about once we deploy the policies, right? We need to make sure that it shows us all the policy violations. So policy violations can be viewed using policy reports. And as policy report is again a Kubernetes object, you can easily access the policy reports using kubectl, or if the pods are getting blocked due to the policies being in the enforce mode, you can look at the events and status and find out what is happening. And Kyverno also provides different metrics, right, for viewing admission review latency, policy execution latency, and all of that. And these can be easily integrated into your Prometheus and Grafana, and you can visualize all those metrics in Grafana. And you can also easily integrate this with OpenTelemetry as well. So the screenshot shows what are the different policies and different metrics here. So once we have deployed the policies, it never ends there. There are always scenarios where we have to make the changes, you have to update the changes, and there are applications who may not be compliant with the policies, and they have to file policy exceptions. In those scenarios, all of that can be easily managed using any GitOps tools like Argo CD or Flux and so on, right? Because they're all native to Kubernetes, and they can be easily managed with GitOps tools. So to sum up, policy as code can be a game changer because it automates security end to end. And we have seen how easy it is to do that with Kyverno, as it covers all the 6 phases of the policy as code lifecycle. So we would love to hear your thoughts on this presentation, and happy to answer any questions you may have.
So amongst all your different applications, there's one additional thing that I found myself doing, and I'm kind of this is a kind of question for everybody. So when I'm working with Helm charts, one Helm chart's better than another, and a lot of the times they might not make certain properties available. And I found myself, once I had Kyverno in place, I was like, oh, I can modify that pod annotation or something like that that wasn't made available. So I kind of found myself using it almost as just a generalized almost mission controller, so I didn't have to write one myself. I could just make that modification happen. Is that something you see other people doing? Is there a better tool for doing that type of stuff? As more of a configuration tool than necessarily a policy tool. I feel like it's a little hacky when I've done it. I'm I don't feel
Right.
it doesn't feel good, but it certainly works. It solves the problem.
It's a great use case for mutate policies. Yeah, we'll have to add that to the list. Thank you for sharing, right? That's right. No, but certainly, where if you can't do things with customize or with other things, Kyverno mutate policies can also work. And you can also apply them in the pipeline, right? So it doesn't just have to be at admission controls, but that's a good way of also putting something in, yeah.
Used YTT to do that kind of thing.
YTT?
Yeah.
Got it.
YAML templating.
Okay.
Basically pipe the output of Helm through YTT.
I see.
Yeah.
Okay.
Yep, so several options. So I think we're out of time, and yep. So thank you all for staying, and certainly reach out to us if you have any questions.
Thank you.